Hello, everybody. I'm Sarel from Israel. It is honor for me to participate in such important conference. I want to thank Mr. Manish Operty for inviting me to share some knowledge I've gathered over more than 40 years in the industry. With your permission, I will share my presentation with you. It is a privilege It is a privilege to live in such revolutionary epoch and to be a part of historical changes which will affect us all in the near present, not even in the future. Like evolution in Darwin's theory, those who adopt changes shall most likely survive and live in the new world. I've been dealing with the technology for about 45 years as entrepreneur, engineer, manager, leader, and mentor. For the last 6 years, I've been the founder and the CEO of SmartSense. Now I will do my best to show you in the next 20 minutes what is all the fuss about Industry 4.0. Nowadays, most of the time, I'm dealing in the world of Industry 4.0 with a lot of aspects, such as solution architecture, roadmap, the gap between the current status, and what is the way to get 4.0, teaching deeply in the academic 4.0, the concept, technologic, methodologic, and mentoring startup in that area. When we are speaking about Industry 4.0, I will say 4.0 is the same. We are speaking about revolution. The fourth industrial revolution began in 2011 at Hanover, Germany. Today, about 10 years later, we should behave like one who is standing on the edge of the cliff and contemplating about being obliged to take crucial long-term decision in a very short time. Think big because the topic is huge and we will and they will accompany us in the years to come. Act locally, try it in small, discrete place with a small system, do proof of concept with a clear KPI as much as possible, depending on your knowledge, resources, budget, and cooperation culture. But we must start now, not to waste any more time because it is like a tsunami. Suddenly it will hit us in the heart of our business. Industry 4.0, in one word, it's all about data. And in two words, it's a huge big data, or what we are calling for analytics, the predictive analytics. Let's dive a little bit. Until the first industrial revolution, humans used either animals or muscles power to drive machines. About the year 1790, the world's population was about 750 million people, approximately, most of whom lived in and died not further than 30 kilometers from the place where they were born. With the invention of the first industrial steam engine, which was a loom of weaving closet, and the development of the steam locomotive, people and goods were much more mobile using trains. Commerce all around the globe evolved enormously, using now land routes, not only shipping, and the scales were incomparably larger. About 150 years have passed. The year is around 1890, and the world's population is about 1.2 billion people, which consuming food, clothes, and all kinds of goods. And new innovation and services were established, like the telephone and electricity lines. It was the beginning of mass production, and it's called the second industrial revolution. We can see that the flag of the second revolution was mass production, like in the film Modern Times of Charlie Chaplin, or manufacturing lines of Ford Model T in the car industry. Around 1970, the third industrial revolution took place where most of the industry world is today. Programmable logic controller, PLCs, electronics, IT, and computer systems were developed. The fourth revolution was announced at Hanover, Germany in 2011, and it deals with the cyber-physical systems, the world of IoT, Internet of Things, where every asset in the organization has its unique ID connected to the cloud, getting from the analytics, the insights, and that we are talking about now. It is important to understand the inherent problem created by the third industrial revolution. Being a bit short of time, I will give only two examples. The first example, there are time gaps between different layers structuring the automation mechanism diagram. Those were designed in the 70s of the last century, according to the ISA 95 standard. Each system has its own timing and is not tuned as an orchestra member of the holistic structure. We can see on the left the times of each layer in the factory automation. We can see here months, minutes, second, it's not the same. At the right, there is a simple flow of process in the plane downstream. Work order is entered into the machine and the machine starts to work. When there is an unplanned stop, downtime, they collect upstream data status, goes to the DB database layer, and then it waits to the ERP scheduling. We can see how the operation real data on the production floor is actually disconnected in the real time from the IT systems responsible for the whole entire process. The second example, the daily manufacturing manager common dilemma. In this example, the working order was planned to produce, let's say, 100 items within 4 hours. The overall equipment effectiveness, OEE, target planned to be 85. Now, suppose 2 hours before the order delivery, the OEE is 40, the actual. Operation knows by data, not by intuition or his experience, just one thing, that order is bound to be late. What must be done in the real time according to the data? We can increase the machine speed, it will cause more defective parts and the OEE will fall. Then it will cause earlier maintenance for the machine. Does he has the spare parts to the replacement? Second, he can decrease the machine speed, or he pull out this order and put another one instead, which is more profitable to the company. What is all about influence on the bottom line of the firm? We really don't know in the current situation. There is no good answer without having insights, according to the real-time holistic data and analytics. Those were samples of two simple problems. For many more was putting in the front of the German government and the German industry leaders in 2011 at Hanover Messe, and concluded in the Hanover Declaration, the Fourth Industrial Revolution, Industry 4.0. In 2007, 1970, an agreement was signed between the German and the Japanese governments, and all the development countries joined the revolution with the similar name. You can see here Spain, USA, Germany, Turkey, Europe, much more. Generally speaking, there are four smart verticals of Industry 4.0: the product, the production, the maintenance, and the supply chain. The product, we must see the whole way of, of the development and usages process, from the first idea and the concept until the end of the product life. It stays connected to the manufacturer for services, design, benchmarking, and serves with a new business model. The production, new way of operation, and connecting technology production lines such as 3D printing, IoT elements, augmented reality, etc. The maintenance, or PDM, predictive maintenance, to know before the failure occurs and to get by analytics know how and what to do. As a result, we are getting constant and stable streaming of manufacturing due to synchronization of manufacturing and maintenance procedure. Supply chain, getting transparency of the data all over the value chain and the supply chain itself, from raw material and supplier through through all the factory departments until the final customer. Sorry. The driven technology of Industry 4.0. We are using familiar and stable technologies such as IoT, augmented reality, cobots, collaborative robots, 3D printing, etc. Above it all, there must be a reliable, strong cybersecurity system defending data, disabling interfiltration and unauthorized approach to the organization assets. The multi-dimensional integration between the data systems is the game changer of using the technologies. This is on the next slide. In the fourth industrial revolution, we are doing a full horizontal and vertical integration. In fact, we are creating a multi-dimensional integration architecture of the company information system, shop floor, operation technology with IT, with all content world, software, hardware, automation data, IoT, and workflow into almost one uniform entity. Moreover, it is a matter of creating connected system with the supply chain management tools, suppliers, and customers to enable the ability to complete viewing the real-time data on the flow, such as inventory level, customer demands, machine health, and etc. For fully support between all the partners and synchronized activities. Now, we are happy to introduce to you our innovation CTI 4.0 toolkit as a demonstration of the fourth industrial revolution with the capabilities of converting the old machine and production lines to 4.0 state-of-the-art ones at minimal cost and effort. The CTI stands for C, connectivity of all the connected assets in the factory, from single machine multi-sites to multi-sites companies. The T is for transparency of data for all legal participants in the process. I for intelligence, artificial intelligence, putting the data-given insights and wisdom for better decision, operation, maintenance, and business concerning real-time and ad hoc dilemmas by analytics insight solutions. The key elements of the CTI 4.0 are real-time data analytics according to the configuration using OPC communication, protocols, compliance to cybersecurity standards. All of these for getting better yield, performance, and profitability, productivity in the whole company. The CTI architecture contains 6 layers, compliance to Industry 4.0 standards and the VDMA guides. We can see it from the bottom to top in the diagram. I will try to simplify it. The shop floor assets, we are analyzing the touch sensor for what we need to measure, transferring the data to the communication layer and the right protocols to the SQL and MDB database. In the data layer, the analytics layer getting the data from the DB and display it on the dashboard, and we can get insights from there about the process, events, and alert in real time. We can configure and operate the CTI in 5 different ways. A standalone cloud version, shop floor to top floor, multi-sites, predictive analytics. I will briefly show the 5 scenarios. The first one is standalone version for places without the ability to use cloud because of security, lack of communication or regulation, etc. We are getting near real-time analytics according to the sampling data of the on-premises. The cloud version, as we call it, software as a service, SaaS. If we see at the left, there are all the inputs, the PLC, the gateway, the communication lines, connecting to the protocol adapters, the database, and from here, the cybersecurity analytics, the dashboard on the computer here. The data is going to the cloud by real time. This is the shop floor to top floor. We can see all the elements on the organization connected to CTI by OPC-UA connected to the cloud. This is multi-sites. We can put the version before and do it on multi-sites on the world. We can provide the worldwide center services. One place provides services to many customers. Predictive analytics, gathering data from the upper layer, the ERP layer, directly to the analytics dashboard. And here we can see the partial example of the dashboard with all the data and alert that needed. Another view of the data gathering for additional sensor for predictive analytics. We are using analytics called complexity by Antonix, Italian scientist. The strengths of the analyze the strengths of the connection between elements in the physical flow. The automatic analyzation provided by our toolkit show the dominant variable liable to cause the next failure in the system before it happens in reality, hence enabling to repair the fault element and cause minimum disturbing of the manufacturing and supply chain routine. After having dived into the technological depths, back to the revolution. 3 years of implementation, Industry 4.0, technologic and methodologic at the 52 biggest companies in Germany. The results are telling the whole story with significant results. Cost of quality, cost of services, time to market, cost of inventory holding and machine downtime decrease. Productivity, total productivity, labor, supply, forecasting, and accuracy raise up. So this is the whole story. I wish to conclude. Industry 4.0 is not only a technological solution, it's a paradigm shift, changing our concept of how we think, design, work, and do businesses. On the whole flow in general, give what you can, take what you need. It causes a deep change in the company's culture, making the data the cornerstone on which decisions are taken in much more efficient, reliable, healthy, and profitable ways. Think big, act local, but start now because the revolution is here. Thank you very much for your time. And if you need more details, Smart Sense in Israel, my name is Sarel. You can find me on LinkedIn or my site. You can and you can touch with me. Bye. Thank you.